Good afternoon. So this is going to be our first LeetCode problem-solving session. It is currently May, and classes have been out for a little bit, so we understand if not as people are able to come, but for those that are watching online or that are watching this video after we've done this in-person session, thank you for tuning in and checking it out. Hopefully this will give you some more information about what we're doing, solve these first problems that we released, and then we'll discuss some next steps at the end about when we'll pick up this session again in the fall. Great. So to start, we want to give a brief outline. It's not listed on here, but I'm going to briefly go over Anaconda. So we will be using a mix of Python and the online LeetCode problem-solving tool to solve these problems, but we're going to first discuss how to install Anaconda so that you can get to Python. It's an easy way to access. It's like a user interface which allows you to use Python and some other applications on your computer without having to go through the process of installing them individually. From there, we want to discuss the two main problems that we've had this week. The first is the Roman to integer conversion. We'll discuss the logic and the Python implementation for this, and we'll also discuss the palindrome number problem. And we'll break down the logic as well as the Python implementation. And in the end, we'll discuss the complexity analysis, but we're not going to really approach it individually since these problems are very simple and they're very similar to each other. We're just going to briefly overview the complexity analysis itself and look at what these applications are. We're not going to offer much improvements as they are relatively simple, so there's not a whole lot of improvements that can be made here. But for future LeetCode sessions, we're going to go and we're going to do a more in-depth analysis and provide some more optimal solutions. But we're going to get started with the first question. Or excuse me, we'll go ahead and get started with the Anaconda installation. So for this, most of our problems, like I said, they can be solved through the LeetCode website, but we're going to be using a mix of both. I'll be using Python Spider, which is just a user interface for using Python, an application for it, and Ayantha, who will be discussing our second question, I believe his implementation was done through the LeetCode website. So there's two different ways you can do it. So I'm going to briefly open up Anaconda and just show you the website and then briefly show you what our, well, actually I don't have it on this computer, so I can't show you what the application looks like, but I can show you how to download it. So you'll want to go to Anaconda, and you probably have to make an account, and then you just want to download it for Windows here, and they have their additional options here. So you click download, it'll install, and then you can actually open up the Anaconda app, and you can see the different applications available to us. So we have like Jupyter Notebook, which is another type of Python interface, Spider, which is what I use, and you even have access to R Studio and a Anaconda command prompt. Within Anaconda, you can manage your package installations, you can actually create new environments, and there's a lot of different tools you can use with it. And it's a little bit easier for people who are not super tech savvy or into the whole Windows command prompts installing everything. So it's a really easy way to get started using Python, and we recommend it. But if you have any questions, I'll provide my email at the end, and I'd be more than happy to reach out and help anyone install this, or if they have any questions about using Anaconda. So with that being said, let's go ahead and get started with the LeetCode problem solving. So to start, our first question was the Roman to integer conversion. I believe it was LeetCode question number 13. So the main objective for this problem is, given a Roman numeral as input, we want to convert it to an integer value and produce that as our output. A little bit of a background into this: Roman numerals primarily contain these listed here: I, V, X, L, C, D, and M. There are other Roman numerals that do go higher, but for this problem, it's more of the simple or easy problem, so they're going to only focus on these more commonly used ones, as I believe there's like an X bar, which is like 10,000 or such forth, which is it's hard for us to type into a computer. So we're just going to focus on this subset of Roman numerals. In addition to this, it's important to discuss the rules that you'll use with these types of Roman numerals. So to start, generally speaking, it's like an addition. So you'll write out your Roman symbols, such for 2, it would be II, 3, it would be III. But whenever you get up to a number like 4, for example, which is the bottom constraint, you would write it as IV. You don't want to have more than 3 repeating terms for the Roman numeral, and these are our special cases. However, when you have normal cases like 27, you write it out, largest number on the left, smallest number on the right. So it'd be XXVII, which is basically going to go, essentially saying you're adding 10 plus 10 plus 5 plus 1 plus 1, and that equals 27. So that's kind of how the Roman numeral system works in a nutshell, and so we'll dive right into understanding the logic of this question. So behind the logic, again, we want to have an input. Hey, welcome. Thank you for joining us. Awesome. So we just got started. So we just discussed the logic behind the first question, which was a Roman numeral question. And these two are pretty easy, so we're going to kind of do a quick overview of complexity and not go too deep into it. So, so behind the logic for the first question, when you input your Roman numeral, you'll type it in as a string variable, and then we're going to want to map it to this understanding, this conversion between symbol to integer value. And then once we map it, we want to then apply those mathematical operations, those constraints, whether it's adding the numbers together or subtracting them. And then finally, we'll output our desired output, which is our integer value. So in this example, it was 500 plus 10 plus 2, so that gives us 512. We can also break it down into how we want to implement the code in steps. So this may seem a little overkill, but this is just a little bit behind how we want to approach each of these problems and start building these good habits. So the first thing we want to understand is that we're going to need to develop an input-output architecture. So we're going to input a number, and it's going to give us an output. And the next step from there is we want to create our mapper. We want to be able to map these input values to their specific output values. And this can be accomplished using a dictionary. In addition to this, we want to implement our mathematical constraints that allow us to either add our values together left to right or handle those special cases where we're going to need to subtract some values. And finally, we want to output our result. And then here's a quick couple of examples. So again, if we wanted to take dxii as our input, we know that essentially this is going to be a list of values that are 500, 10, and 2. This is what these integers represent. Or it really would be 510, 1, 1, but it's just simplified for this instance. And then we add these together, and that gives us our integer value. For a special case such as 4, we're given the values in a different order. We're given them instead of largest to smallest, we have a small one, then a large one. So it's 1 and 5. And so then instead of adding, now we want to subtract those two, which then gives us 4 as our output. So this next step will be showing us the code implementation of this logic and how we're going to handle these special cases. The practical implementation, the first step is one to define that mapping. So here we're going to use a dictionary to define what each of these Roman numeral inputs is and their corresponding output. From here, we then want to write our for loop, which is going to allow us to iterate through each of the input values except for the last one. And this is the not using that last value is because we want to be able to go back and evaluate if the value is smaller than larger, except for the last value will always be added to it because there is no other value after it, so it couldn't be subtracted from anything. From there, we want to implement an if-else statement. This if-else statement is going to allow us to evaluate if our previous value is less than our following value. If that's the case, then we want to subtract it. That means that we're going to have that special case where we're having only we're having a value where it's like 4, for example, where we can't have more than 3 of the same value in a row. So this allows us to write that number in the Roman numeral sense, and then we can translate that back into an integer value. And then we have our else statement, which is if that's not the case, where it's written previous number or the first number on the left is the largest all the way to the smallest. Therefore, we would just directly add them together. And then for our output, after we've done the subtraction or the addition, or if we've just done the subtraction, we can then add those remaining values together, and that forms our constrained output. It's also important to note that within our definition for Roman numerals to integers, we're also defining our input as a string and telling it we're going to convert it to an integer value. So it's understanding what we're putting in as a string, and it understands what we want it to be output as an integer. I'm going to pass it off to Ayanta, and since we don't really have anyone in the audience, I mean, do you have any questions about the first one? No, okay. Since we don't have anybody in the audience today, we don't really have questions, but again, I'll list my email at the end and be more than happy to answer any questions. I do want to note, I'm sorry, I meant to mention, with the practical implementation, there is also another popular solution on LeetCode, and that is to write the special cases in their own dictionary and to evaluate the two dictionaries separately. So you would have a dictionary of special cases and a dictionary like here we have of normal cases, and then if your input is a special case, you would refer to the special case dictionary. It's about the same complexity, it's just more code. So we opted to go with something that has less code and applies a more logical thinking, more human thinking to it. Because as humans, we don't potentially know all these special cases ahead of time. So this is more about how we would go through the problem and how we would logically think through it. So now I am going to pass it off to Ayanta to do question 2.
All right, thank you, Durant. Okay, let me go through the question 2 here, which is called palindrome numbers. So the objective of this question is you are given an integer, so so you have to check whether this integer is a palindrome number or not. It's like you are given an integer, so you should return true if it is a palindrome number. So otherwise, you should return false. So first of all, what is this palindrome? So it is defined as a word that's spelled the same forward and backward, such as race car. So if you take the race car in a forward way, so it is race car. So when it comes in a backward way, it is again race car. So this is the one of the important thing you should know when you get into when you dive into this problem. At the same time, the palindrome is defined for words and also in numbers. The same thing is going to be happen. It's like, for example, 1 to 1. You know, if it is a forward way, if it is a 1 to 1. When it is comes in a backward way, it is again 1 to 1. So it it's going to be same for numbers. And when you consider about these numbers, so you should be aware of the certain properties of the palindrome numbers. The first thing you should notice, the all single digits values such as the base 10 systems, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are going to be palindrome numbers. So this is very important. At the same time, how about the negatives? The negatives, are they going to be palindromes? No. Let's say take an example of negative 1 to 1. So when it is going to be, if you if you take a backward copy of negative 1 to 1, it's going to be 1 to 1 and negative sign, which is unusual. So therefore, we can see that, we can observe that the negatives are not going to be palindromes. So those are the important properties when you think about the palindrome numbers, and you should know to solve these problems. I mean, before you deep dive into this problem, you should know about these palindrome numbers. Let me give you a logic behind this question. So the thing is, so you are given an integer value. So this integer value, so you should write a code, or you should write an algorithm to check whether your integer is, if it is an integer, if it is a palindrome integer, you should return true. Otherwise, you should return false. So, and the question says that could you solve it without converting without converting this integer into a string? What does that mean? Let's say you are given a integer, and this integer you can easily convert it to a string. Then I hope you guys, at least you. You have certain experience of coding, so comparing these characters in a string is very easy. So your problem becomes very easy compared to numbers. So in string, what you do, you can compare your last digit and the last character and the first character and the second last character and the second character, and if they are going to be same, if they are same, then you can return it as true, or otherwise I would say it is a palindrome number. But you should not do, the problem specified that you should not do it. So you should get rid of this converting part, and you should use the mathematical the mathematical expressions and operations to approach in a solution. So let me go in detail about this problem. First step, or first thing you should do, you should create a backward copy of a given number. Let's say your number is 1, 2, 3, 4, and let's say we have another variable, and this variable is initialized to 0. To keep our backward copy. So in first thing, you should, this is a way of finding the backward copy of your given number. The first thing you should do, you should modding by 10, and which is, when you think about this Python programming, you should know that, when you use this mod operation, you may end up with finding the remainder, right? So the remainder is 4, and so we keep that in a backward copy. And if we divide this in, integer division, so you may end up with 1, 2, 3. So then your 1, 2, 3 is going to be initialize or your variable. You are assigning this 1, 2, 3 as another variable. So your initial value now updated to 1, 2, 3, and your backward copy is 4. This backward copy comes from 0, your initial value multiplied by 10 plus 4. So this is the way you find this backward copy. Then what we have 1, 2, 3 as an initial value, and if we divide, or if we mod by 10, the remainder is 3, and the backward, if we divide this by 10, it's going to be 12. Now initial value is 12. Now the backward copy comes as 4 multiplied by 10 plus 3, which is 43. Now you can slowly see that the 43, our backward copy should be like 4, 3, 2, 1. So if your C is going to be 0, if C getting 0, which means that your backward copy comes as 4, 3, 2, 1. Now we can compare this backward copy to the initial value or original value to return, if they are same, we can return true. However, when you think about the optimized way of finding this backward copy, or finding this solution, or approaching this solution, let's take, instead of taking this whole number, let's take only use the half of the number. So what we're going to do, we reverse that, the second half. If it is same as our original first half or original value, then we can return it as palindrome number. For example, it's going to be, let's say 1, 2, 2, 1. The backward copy or backward of the second half is going to be 1, 2, and 1, 2 is same as the first half of the 1, 2, 2, 1. So then we can easily return true in this case. This is the practical implementation using Python. Actually, this is going to be the Python 3. So if you're using Python 2, some the minor changes should be applied. So the first step is going to be initialize the variable for assigning this backward copy. So we use b equals 0, and this is for backward copy. In step 2, we should eliminate the negative values, as I mentioned earlier. So the negative values are not going to be considered as palindrome numbers. At the same time, one more important thing, if you have a positive value with last digit 0, it's not going to be a palindrome number. So therefore, we can easily return false. And in step 3, what we're going to do, we use the while loop, check the condition of this backward copy and the first half and the second half of this backward copy to return true if they are going to be same. If otherwise, I would say we can return false. So this is going to be the third step. The whole step are going to be success in the LeetCode platform. So in this LeetCode platform, they say that the runtime is somewhere 90 milliseconds, and which is faster than 45% approximately. So here is the complexity comes of our two problems. In first question, the time complexity is somewhere the big O notation with n. The n is going to be the number of digits that we have in our given whatever given integers, or given characters in your first question. In question 2, its time complexity is going to be same, the big O notation of n, and the space complexity is somewhere with big O with 1. So if you could remember, in first question and the second question, we just allocated one variable. So therefore, the space complexity is O1, and the time complexity. If I hope you guys know what is this time complexity and space complexity. That if you couldn't remember, so it's if I recall that the time complexity is going to be somewhere which is defined as the time taken to execute certain instruction that we given for a certain algorithm. So that is going to be the time complexity. The space complexity is defined as the time. I'm sorry. The space is going to be the memory that we allocated for a certain algorithm. So those are the two questions that we have discussed in our first LeetCode meeting. Let me pass this to Durant and.
Hey, so great. Thank you all for tuning in. Thank you, Anthony. Good job breaking that question down. I love palindromes personally. Race cars are one of my favorite ones. I was just telling the other day about it. They're fun. But yeah, so that was just a quick taste. There's just some really easy questions to get started with for this. So we want to continue this into the fall. So briefly before I end this, I want to talk shop. So to start, if you have any questions, please feel free to email me. And I didn't put Anthony's email on here. I should have, but I will forward them to him if it's about question 2, and I can answer them if it's about question 1 or if it's about Anaconda. And again, we really recommend Anaconda if you want experience using Python or a Python interface. It's a little bit more homey or personable than using the LeetCode, in my opinion, but LeetCode allows you to get that integrated runtime as well as a comparison to some of the other solutions. So there are benefits to both. But I just want to wrap it up by discussing in the fall. So for the fall, we're going to plan to do these more frequently, and we're going to plan to do them more scheduled. We initially launched this LeetCode in the spring, and we kind of ran towards the end of the semester, but everybody was busy with finals, so we weren't really able to kick off that many sessions. So this will conclude our spring 2022 sessions, but we'll kick off again in August in the fall, and we will be sending out emails, again, reminding everyone. And if you join this GroupMe link here, hopefully you can scan that from your phone or from your computer. If you join that GroupMe, we will gladly keep you up to date with everything that's going on, both with our Informs and with our LeetCode. This GroupMe is particularly for LeetCode, but we'll also be reposting some Inform things there too. So again, thank you all for coming, and feel free, if you have any questions, let us know. Have a good summer.